Right. So we're starting off with number 36, and it says basic answers to questions 36 through 40. Sorry, on the information below and on your knowledge of Earth and space science. Some questions may require the use of the 2024 edition reference tables for Earth and space science. So, once again, one of the first things we do, right, because this is an exam that does focus on limited time. So it says which claim, right? So this is a statement, right? Identifies a benefit. That means that something good needs to happen, right? Something good. All right. Of developing and managing the Libby Dam hydroelectric project after its construction. So we're making a statement, right? Which claim identifies something good, right, that's occurred after the dam has been constructed. All right. Well, when I look back, let me see about some information about the dams, right? It's a very short reading, so you may not even have to scan it. You can just read through it, right? Dams and other structures are also put in place in river systems to help reduce life and property losses to residents living near rivers due to flooding. Dams are also built to generate electricity, right? So the purpose of dams, I'm just going to highlight some good things, all right? Because we're looking for benefits. They reduce life and property losses, and they also build electricity. And the graph below shows river flow rates on the Kootenai River in Montana in cubic meters per second. So now I'm looking at the key. All right, I see that the dark line represents the dam before the river discharge, which refers to the amount of water flow, right? The amount of water flow. All right. So the dark line represents before the dam was constructed. The gray dash represents the dam after it's been constructed. Okay. So, in a question like this, remember we're looking for a statement that is generally true. You can almost look at it as a true and false statement. So it says the river rates have increased for the entire year, increasing the amount of electricity generated. Have the river flow rates increased for the entire year, right? Remember, after its construction, if that was the case, this dash line would be much higher throughout the entire year, right? Because the question says the river flow rates have increased for the entire year. But when I look in May and June. After the dam is built, right? I see the river discharge is lower, right? It's lower in May and June compared to before the dam was built. So that's not true. Let's look at two. The river flow rates have decreased during the winter months, increasing the amount of electricity generated. It has decreased during the winter months. So let's take a look. Remember, we're focusing on after it's been built. So winter months, I see January here, and I see December right here. And remember, after it's been built, it's saying the river rates flow have decreased. But that's not true because after the dam has been built, right, the dam construction after the river flow values is actually higher compared to the dam before the dam was built. I see over here the winter months. You see these dashed lines right here? It's higher than the dark bolded line. So river flow has actually increased during the winter months, not decreased. So this is not true. It says after dam construction, the river flow rates changed less throughout the year and allowed for more control of electric generation. Well, we know dams are used to generate electricity. That's true. Let's see if it changed less throughout the year, right? When I take a look, I see a huge gap between its maximum river discharge and its minimum discharge, right? So it fluctuates a whole lot if we noticed, right, throughout the year before the dam was built. Now let's take a look after the dam was built, right? You see how the numbers they slightly increase over here, right? They slightly decrease over here, but the values look like they have changed less throughout the year, right? It doesn't fluctuate as large, right, or as big as before the dam was constructed. So this is a possible answer. I'm gonna keep that in mind. When I look at four. After dam construction, the river flow rates changed more throughout the year and allowed for more control of electric generations. If that was the case, right? If that was the case, and we're saying after the dam has been built that it changed more throughout the year, that means that for our gray dash line, we would see even a bigger change from minimum to maximum, right? That means instead of it being here, it may be something like up here, right? And when it decreases down, it may be something like right here, okay? So that's just letting you know there's a large change in river flow. After the dam construction, that would have been the case. We would have seen a completely different graph. So that's why the best answer is choice three through the process of elimination. All right, next I'm looking at 37. They give us the model below shows information about a river system, river ecosystem with a dam. All right, so it says which statement correctly identifies a relationship between the hydrosphere and the biosphere in a river system with reduced water flow below a dam, right? Reduced water flow below a dam. Okay. So once again, I see which statement correctly identifies a relationship between the hydrosphere, which represents the water, right? All the water in the earth, and the biosphere, which represents all the life that includes animals and plants, right? So plants, you know, and animals as well. In a river system with reduced water flow, okay? So let's take a look. Lower water levels below the dam will lower the water table and will increase biodiversity of native fish and birds. Let's see if that's true. Because when I scanned, right? When I scanned, you're saying that it will increase biodiversity, but I see right here it says reduced biodiversity when they're talking about the ecosystem within a dam. So if you're telling me it's going to reduce biodiversity, it can't say it will increase biodiversity. So it can't be that. Remember, I'm choosing the correct statement, right? Number two, the water table will rise and provide a benefit to agriculture areas, industrial areas, and wetlands. Let me look at agricultural, industrial, and wetlands. So I'm scanning. Do I see something about, let me see. I'm doing this. Allocate water, wetlands. Here we go. I see something about wetlands. Right? Because we were looking. It says wetlands dry out unless water is available, right? So even though I didn't see so much about industrial areas, I did see something about wetlands, and it says it will provide a benefit to wetlands, but it says right here, the shrinking habitat, wetlands dry out. That doesn't sound like a benefit, so I'm going to cross that out right there. Let's look at three. Reduced oxygen levels in the stream will create algal blooms, which improve habitat. for fish. Let's see, we'll create algal blooms, which improves habitats for fish. Well, let me see. I do see, right, creates algal bloom, right? I do see that, but does it say anything about fish? Well, it says many native freshwater fish and birds are threatened with or at risk of extinction. So, which improves habitat for fish, but it tells me right here, fish and birds are threatened or at risk with extinction. So that it's almost as if the model is canceling out options for me. Okay. So last, just by process of elimination, a decrease in water flow promotes saltwater intrusion, which is harmful to certain plants and animals. Okay. I definitely see it talks about saltwater intrusion, right? And it says right here, it says extracting groundwater can cause saltwater to move into aquifers that are near the coast. This makes groundwater unfit, right, for irrigation and drinking. So that makes sense why it would be harmful to certain plants and animals. It says right here, this makes groundwater unfit for irrigation and drinking. So that's why choice four is correct. All right, so 38. 38 says use the model to construct a claim, right? So I'm going to make a statement about the amount of coastal sediment deposited by a river system before and after a dam is constructed. So when I look at my first thing to construct a claim, right, I'm going to state something as true. I'm making a statement that is true, right? About the amount of coastal sediment, right? Coastal, according to our common terms of the regions, coastal describes being near the ocean, and sediment describes what does sediments describe? Small particles of rock or soil. Okay. And another word that we saw was the term deposited, right? Meaning laid down or dropped. Okay. So it's saying construct a claim about the amount of coastal sediment deposited by a river system before and after a dam is constructed. So a river carries sediments. It carries sediments and they drop off these sediments, right, at the coast, right, or by the ocean. I'm going to look to see if the model tells me anything about sediments, deposition, anything at all. I'm going to look to see. So when I'm looking, there is a line that points here, and it says it's an image that says barriers to migration and loss of sediment transport. Hmm, I think that's something that is key. Right here, it says loss of sediment transport. That means that because of this dam, right, there's a lot of sediments that's not being transported. Okay, how can we make a conclusion based on this right here, right? Because it says barriers to migration. So maybe, right, the sediments before the dam, sediments were able to flow a lot more easier. But maybe after the dam, right, now there's a loss of sediments transport, which means not as much sediments has been transported, right? So if I'm going to make a statement now about what we just said before, I can say, right, more sediment would have been dropped off or deposited before the before the construction of the dam. After construction, right, more sediments. more sediments have been trapped behind the dam. You could have also even included what is stated right here, right? You could have also said, after the construction of the dam, there was a loss of sediment transport. There was a loss of sediment transport, right? Which means less sediments have been deposited. And that's it. That's it. All right. All right. So 39, it says based on the river ecosystem with a dam model and the diagrams. So I'm going to be possibly looking at more than one diagram and model. Which evidence-based statement correctly identifies how the availability of fish spawning habitats have influenced commercial fishing above the dam. All right. So I see a couple of keywords. I'm just going to look. All right. I see about commercial fishing, fish spawning habitats. When I look, I see fish spawning habitats. All right. And when I look, I see the free flowing river, right? This must have been before the dam, and I see a whole lot more of fish spawning habitats, right? I see a lot more of these circular things that represent that. Now with the river and the dam and reservoir, I don't see as much. So that's something key to keep in mind, right? Then it also says I'm looking for anything about habitats right before the dam, right? So this area right here, I see barriers to migration, loss of sediment transport. All right. Let's see if I can now answer this question by just removing my choices to see which is true. It says dams increase water levels upstream, decreasing fish spawning and decreasing commercial fish opportunities. Well, when you talk about above the dam, right? When the dam was created, we do see that the fish spawning habitats have decreased here. Do we see that? Right? And before it was a free flowing river, and now it looks like it's just one big old lake, pretty much. Even in the diagram that I see over here, you can tell that the water levels look pretty high, right? That's building up around here as well. So that actually this might be a potential answer, especially because I see a decreased fish spawning. Number two, dams increase dissolved oxygen downstream, decreasing water quality and decreasing commercial fishing opportunities, right? That may be true. The only issue is that they're talking about above the dam. And we know for a fact that water quality has definitely been decreased after the dam, right? Okay. If I look at three, it says dams decrease water levels upstream. Just the fact that you're saying it's decreasing water levels upstream, that makes it wrong, right? Increasing fish spawning and decreasing commercial fishing opportunities. The word spawning, right, it leads to production. So if you have more fish being born, then it would increase commercial fishing or fishing to buy and sell to the community. So definitely not three. Um, yeah, because if you're gonna have more fish, then that means you'll have more fish to sell. And four, dams decrease dissolved oxygen downstream, increasing water quality and increasing commercial fishing. Dams decrease dissolved oxygen downstream. So once again, we're focusing about commercial fishing above the dam. So we're talking about before, right, the water has to pass through. Okay? So that's why my best answer is going to be choice one. All right. And number 40, it says use the cost of flood damage in a 2,500 square foot home table to calculate how much a homeowner could potentially save. We're going to calculate how much a homeowner could potentially save after spending $56,250 to raise their 25 square foot home to avoid being impacted by a 24-inch flood. So it says use the cost of flood damage. All right. So let me read here. It says some residents in coastal areas impacted by flooding have decided to place their existing homes on stilts above identified flood water levels. The data table shows some information about flood damage, and it says the cost of flood damage in a 25 square foot home, right? Now, this particular home is focusing on what amount of flood, right? The 24-inch flood. So the damage that could potentially occur in a 24-inch flood, the damage amount is $87,326. That's how much damage is going to cost, right, in a 24-inch flood. Now, what does the problem say? This homeowner says they spend $56,250 to raise their 2,500 square foot home, right? And the reading, right? The reading says how some residents that's been impacted at flooding decided to place their existing homes on stilts above identified flood water levels. So they're spending some money to put their homes on stilts to avoid the damage that could cause. So if a homeowner spends $56,250, right? How much did they save if the damage that would have been done is 87,326, right? So this would have been the amount, right, that they would have paid if flooding has occurred. And this is how much the 56,000 is how much they spent. So how much did they save potentially by now having not having damage being done to their home? And so therefore I'm going to subtract the difference. And you get up 31,076 dollars. And that's going to be your answer for the amount saved. All right, the homeowner spent 56,250. The damage to repair, right? The cost to repair the damage would have been 87,326. So they did save the difference between the two. All right. The next video will have the other three questions. All right. Make sure to like, share, and subscribe. Have a wonderful, blessed day.